In this lesson, we're going to look at inverse functions of log and exponential functions. And if you remember when we first talked about log functions, we said that they were the inverses of exponential functions. And we looked at that on a graph by reflecting an exponential function over the line y equals x to see how the log function comes to be. And now what we're going to look at is we're going to look at doing this algebraically. So for this first one here, I want to find the inverse of this log function. So basically what this means is my final answer should end up being some kind of exponential equation. So what we're going to end up doing is, if you remember the process when we do these inverse functions, the first thing we do is we set our function equal to y. So in this case, my function's already equal to y. And then I switch the x's and y's. So it's going to be x equals log base 7, 49 to the y. And then we have to solve this for y. So what ends up happening here is we're going to drop the log and swing the base, since we have a log over here. So drop the log, and we're going to swing the base. So this becomes 7 to the x equals 49 to the y. And we're solving this for y. We're trying to get y by itself. So remember, whenever we have our two bases, we want to rewrite the bigger one so that it's a base of the smaller number. So I'm going to rewrite 49 as 7 squared. And then remember, an exponent raised to an exponent is the same thing as multiplying the exponents. So at this stage, I have 7x equals 7 to the 2y. And so let me just rewrite this. So then what happens is, since we have the same base and these two sides of the equation have to be equal, what that tells me is that the exponents are equal. So x equals 2 to the y. And I solve this for y. So divide both sides by 2. And we get y equals x over 2. So then for the next one here, we're going to go through the same process. So first step is to set it equal to y. Second step is to switch x and y. So we're always going to switch x and y, just like up here, and solve for y. So I'm going to go ahead and I'm going to switch this. X equals 2 to the y. And now I need to solve this for y. So this is where we're going to be using logs. So we started with an exponential function. Remember, we're expecting to get out a log because logs are the inverses of exponential functions. So the only way that I can actually solve this for y, or to get y by itself, is if I rewrite this in our log form. Because remember, we have a form of logs and exponential functions that are equivalent. So if this is the exponential form, the log form that's equivalent to this is y equals, we take log of whatever the base is, so base 2 of x equals y. So base 2, log of this, and then the log always equals the exponent. So there's our inverse function. So that's really how logs come into play. And then if we look at the next one here, the next one we have, again, another exponential function. So we expect that our final result will be a log. So we're going to, again, switch x and y. So x equals e to the y. And get this so that it's solved for y, which really means get it into log form. So it's going to end up being y equals log, and you keep the base of x. And remember, whenever it's log base e, this is the same thing as y equals ln of x. So basically, we've just shown that e to the x and ln of x are inverses of each other algebraically. The same thing goes for y equals 10 to the x and log base 10 of x.